This is Unit 11, Lesson 11, Applications of the Discriminant, and your objective is there. Let's go ahead and get started. So when we talk about the quadratic formula, the expression inside the radical is called the discriminant. Okay, we've been through that. So the discriminant is right here. It's b squared minus 4ac. Again, it's the expression under the radical, which means that it does not include the square root sign. So b squared minus 4ac is the discriminant. And by itself, the discriminant can tell us how many solutions a quadratic equation has. And here's why. Okay? Let's say I asked you what the square root of 9 was. Okay? Well, we know that can equal positive or negative 3. Okay? So the square root of 9 has two solutions. It's got a positive 3 and a negative 3. If I asked you what the square root of 0 is, I mean what times itself is 0, well, there's no positive and negative answer, it's just 0. So there's only one answer. Alright? And then if I asked you what the square root of a negative number was, okay, we talked about that as no solution. There's no answer, no real answer, okay? Because we can't have the square root of a negative number unless we incorporate imaginary numbers. And in real life, so if I give you like a real life example, a word problem, pretend I wanted you to solve a falling object model for the time. If you got the square root of a negative number, we can't have that, okay? Because time is a real thing. And so we cannot have an imaginary answer like 2i to represent time. So when we talk about the discriminant can tell us a lot. So let's look at that stuff on the next slide here. When the discriminant is positive, then the quadratic equation has two solutions. So for example again, okay, the square root of 9 is positive and negative 3. So when we've got the discriminant, the number under the radical, is positive, then there's going to be two solutions. Likewise, when we solve and we get 0 underneath the radical as the discriminant, right here, so if we solve b squared minus 4ac and get 0, then there's only one solution, and that solution is 0. Okay, then if we get a negative answer, again like this, and our discriminant is negative, then there's no real solution. All we have is an imaginary solution. So no real solution. Again, we do have a solution, imaginary numbers, but no real solution to it. So one more time. Again, the discriminant, b squared minus 4ac, when that comes out positive, then the quadratic has two solutions. When it comes out 0, the quadratic only has one solution, and when it comes out negative, the quadratic has no real solution. Okay? And this is particularly helpful when we talk about real-life applications, which we will on the last slide. Okay? Now let's go on to another slide to talk more about this. Okay. On this example right here, all I want you to do on this one is find the discriminant. Okay, so I'm going to write that. Find the discriminant. So again, what that means is find b squared minus 4 times a times c, and tell me what that number is. Okay, so the first thing that we should do is write this in ax squared plus bx plus c form. It's already equal to 0. Okay, so this is 1x squared plus negative 6x plus negative 5. Okay, so we've got a equals 1, b equals negative 6, and c equals negative 5. Alright, now I just want to find the discriminant. So I'm going to plug in the numbers to the discriminant part of the quadratic formula. So b squared, that means negative 6 squared minus 4 times a times c. Well, negative 6 squared, negative 6 times negative 6 is 36, minus 4 times 1 is 4, and 4 times negative 5 is negative 20. Okay, well then that would change to 36 plus positive 20, which is 56. So the discriminant in this case is 56. Alright, so we just found the discriminant. Now again, the good thing about that is that if we're solving the quadratic formula, we know that there has to be two answers, or two roots, because this number is positive, and the answer would be plus and minus the square root of 56. Okay, so we could have a positive and negative answer. And let's go on to the next slide and find some more applications using the discriminant. And these examples say, find the value of the discriminant and tell if the equation has two solutions, one solution, or no real solution. Okay? So again, just by finding the discriminant, we can tell how many solutions we have, And so for like a graph, we could tell how many times it crossed the x-axis, or does it even cross the x-axis? Alright, so first thing again, want to do here, and we'll switch to the red pen, is write this in ax squared plus bx plus c equals 0 form. So this is 1x squared plus negative 3x plus negative 4 equals 0. Alright, so when we do b squared minus 4ac, I'm going to have negative 3 squared minus 4 times my a times my c. Well, negative 3 squared, negative 3 times negative 3, that's 9, minus 4 times 1 is 4, times negative 4 is negative 16, and 9 minus negative 16 is 25. Okay, so we'll call this one A and B and C. So A has two solutions. Means that that graph will cross the x-axis twice. It has a positive and a negative answer because, again, I can find the square root of 25. It's positive. So it has two solutions, plus and minus. Alright, next example here again, ax squared plus bx plus c form, so it's negative 1x squared plus 2x plus negative 1 equals 0. Now we're going to plug it in. Again, b squared minus 4ac is the discriminant, and tell how many solutions we've got. Well, b squared, that's 2 squared minus 4 times a, which is negative 1, times c, which is negative 1, and that equals 2 squared is 4, minus, and then 4 times negative 1 is negative 4, times negative 1 is positive 4. And that equals 0. So B has one solution because the discriminant is 0. And the only square root of 0 is 0. And now we'll look at the very last example. Again, ax squared plus bx plus c form. And we're going to plug it in for the discriminant. So b squared, that's negative 2 squared, minus 4 times my a is 2, times my c is 3. Negative 2 squared is 4, minus 4 times 2 is 8, times 3 is 24. And so that equals negative 20. And since I can't have a real solution, okay, when we have the square root of a negative number, then the answer is no real solution. Just an imaginary solution. Alright, and that's how we can use the discriminant to tell how many solutions there are. Okay, and again, the nice thing about this that we can do is we can make a quick check. We get a real life example and see when we solve the quadratic formula, instead of going all the way through it, we can look right away and tell, is it even going to be possible to solve, or am I only going to get imaginary answers? And if I only get imaginary answers, then it's not possible to have a solution to a real life problem. Okay, so then I don't have to waste all my time. Now let's go ahead and look at the last slide of examples. Okay, so this example says, you attach a stick to a rope and your friend is preparing to throw it over a tree branch that is 20 feet from the ground. If your first throw has an initial velocity of 29 feet per second and the initial height is 6 feet, will the stick make it over the tree branch? So basically I want to know, will the stick that I throw make it at least 20 feet in the air? Okay? Well, because we're throwing something, we're going to have the vertical motion model. And I want to see if that stick will make it to 20 feet high or not. So I want to know, is it possible for it to have an ending height of 20 feet? Okay, and how long would that take? So I'm going to plug in 20 for the ending height. And I'm throwing it upward, okay, so it's plus 29 t plus the initial height is 6. Alright, so now if I go ahead and set that equal to 0, I'm going to subtract 20 on both sides. It's going to be negative 16t squared plus 29t, and then plus, and 6 minus 20 is negative 14. Alright, and that all equals 0. So basically, all I'm trying to find out is this even possible to make it over the branch? Well, if it is, that means I have to have solutions. Okay? So I can use the discriminant to tell if I'm even going to have solutions or not. So I'm going to go ahead and figure out b squared minus 4ac and see if I'm going to get a number or not. Okay? If I'm going to have a solution or no solution to this problem. If I have a solution, then that means it will make it over the tree branch in whatever amount of time that is. And if I don't have a solution, then that means that it's not possible. Okay, I didn't throw it hard enough. Well, b squared, that's 29 squared. Sorry, I didn't really need the parentheses, but we have them in there anyway, it's okay. Minus 4 times negative 16 times negative 14. Alright, well, if I take 29 and square it, I'm going to get 841 minus 4 times negative 16 is negative 64 times negative 14. That's positive 896. So then 841 minus 896 equals negative 55. So my discriminant is negative. That means that that is not possible. Okay? So A is no, because there's no real solutions to that, because my discriminant is negative. Alright? Well, let's try the same thing again. We're going to use the vertical motion model for this, but we're going to change the velocity to 32 feet per second. Keeping the initial height the same. Alright, so pretty much we're assuming that the person is about 6 feet tall, is what we're saying here. That's where they're starting to throw from. And we want to know, will this velocity less get over the tree branch? So again, the tree branch is 20 feet high, so I want to know, will it make it at least 20 feet? Can it end at least 20 feet? Okay, equals negative 16t squared, plus the velocity this time is 32t, and again, positive velocities on both these because we're throwing the stick upward. Okay, plus 6. So now again, if I subtract 20 from both sides, I've got negative 16t squared plus 32t plus negative 14 equals 0. Okay, we're going to use the discriminant to tell, is this even possible? Can I have solutions or not? So I'm going to go have 32 squared minus 4 times negative 16 times negative 14. And this time, 32 squared is 1024 minus, and I already did 4 times negative 16 times negative 14 before, that was 896. So 1024 minus 896 gives me a discriminant of 128. That is positive, so that means yes, the stick will get over the tree because we got a positive discriminant. Now notice, I didn't actually solve for the time on these ones because it didn't ask me to do that. It just simply said, will it make it over the branch? So is it possible to have a solution or is it not? Okay, and those are the kind of problems when it's good to just have to use the discriminant, and now we don't actually have to solve it because we already answered the question. Alright, and that's it for your lesson. Happy homeworking.